Today is just looking at some data that's actually pulled from maybe what you've been seeing in the media or from the real world. So the first one I want to look at is this little curve, this what we call a bell curve right here. And a lot of you have probably seen this. There's a lot of talk about flattening the curve. Now, what does that mean? It means it's without protective measures, so without any intervention as far as quarantining or safe distancing goes, the time since the first case of the coronavirus would spike at about here. And it would surpass what the healthcare system can hold. So they won't have enough hospital beds, they won't have enough ventilators. Now, with the protective measures, so with the quarantining, with the safe distancing, it would spike at about here. So it's going to prolong the staying of the virus, but it's going to keep it within what our healthcare system can handle. Now, what I want to look at is how does the difference between these two graphs, how does flattening the curve affect the average number of cases? So if you think of what we call a bell curve, this is actually another word for that is normal distribution. A lot of natural phenomenon that occurs in the world follows a bell curve. So it starts out kind of slow. So you remember there weren't very many cases at the beginning of this virus, and then it spikes, but then it gradually goes back down. And a lot of different natural phenomena follow this, but it's especially true with things like diseases or things of the like. So what flattening the curve does essentially is it takes that average number and it prolongs it. So we don't have, so if you cut this in the middle, this is the average number of cases are going to fall about right here. So it decreases the maximum number of cases, but it lengthens the time that we have the cases. So about a little over 50% of the cases occur within this range right here. So this is the one for without protective measures. This is the one for with protective measures. About half of the people that are going to get the coronavirus are going to occur within these two time frames, and then they're going to kind of level off. And so this bell curve is going to show us that 50% of the people are probably going to get it in this time period, whatever that time is. This axis isn't labeled, so we're not 100% sure. But then it's going to level back off. And so it kind of lowers the average of the maximum. So that a lot of people are still going to get it because it's going to spread out over time. But it's going to lower it to where the healthcare system can actually handle it. So let's look at another example. We talked about histograms today. So let's look at some histograms. This is the use of social media platforms by age group. So remember, the big thing with histograms is being able to divide it into different ranges. So these histograms divide it into ages. So you have 18 to 24 years, 25 to 29 years, 30 to 49, 50 to 64, and 65 plus years. So let's look specifically at Snapchat. So remember, what kind of population distribution does the data come from? Well, it's coming from different age groups, and it looks like the data is mostly leaning towards the younger. Okay, so the data is kind of spread out, but is still leaning heavily towards the younger age group, the 18 to 24. So is the data symmetrical or skewed? Now remember, for the data to be symmetrical, it's going to kind of have to follow that bell curve. So it would look something like this. It would start out slow, it would probably spike with the two middle age groups, and then it would go back down. But that's not the case. It's skewed towards the younger age groups. So it's skewed towards the 18 to 24 and even the 25 to 29. But once you hit that 30 to 49 range, it drops below 24% of the people that they polled. So now let's talk about outliers. In this case, we kind of do have an outlier, and that's going to be the 65 plus. I don't know about you, but I don't know a whole lot of 65 plus year olds that are on Snapchat. So that's at 3%. So that's substantially lower than the middle two, which is 47 and 25. And then the mode, if you'll recall, is the one that occurs the most. In this case, we're looking at percentages. The highest percentage is going to tell us that the mode is most likely going to be in the 18 to 24 range. So that's just an example of a histogram that is modeling real-world data. And the last one that I want to look at is a box plot. So this is actually a lot of box plots all put together. Box plots are really useful to compare data across the years. So this one is showing me the percentage of the reef's coral cover. So y'all know about the coral reef, and I'm sure you've heard that it's been declining throughout the years, but this comparison of the box plots actually shows us how that's the case. So this is the percentage that the coral reef is covering, and then this is the years. So if you'll look at the very first year that they collected this data, 1985, here's our minimum value. It's probably about 6 or 7%, and then the maximum value is over here at 55%. We have a couple of outliers. That's what these dots are. They're outliers. But then the important thing is, remember, the 50% of our data falls within this box. Our median is right here about 27%. So in 1985, the median coverage was about 27%. But if you go up here to 2012, look at where our median falls. That's right at 10%. That's substantially lower than the 27%, and that's just the median. The max over here is below 25%, and the max over here was at 55%. So you can see kind of it's fluctuated a little bit throughout the years, but the ongoing trend is that the percentage of coral reef cover is decreasing. So box plots can be very useful for comparing data. In a moment, you're going to see a box plot that's going to help you compare data between test scores in two different classes. So that's a really good way to see, especially because it lumps the grades or whatever the data set that you're looking at into quarters. So it's easy to see, where does 50% of your data set lie, which is that box. So keep that in mind as you answer the next few questions on the self-evaluation.